They were never built to last half a century. Most machines we send into space stop working after a few years, some after only months. But these two, they just kept going. Launched from Earth in 1977, the twin Voyager probes were meant to explore Jupiter and Saturn, take a few photos, and then fade into silence. Instead, they became something no one expected: survivors. Their computers had less memory than a phone contact list, their data stored on magnetic tape, and their power designed to fade slowly over time. By every expectation, they should have gone quiet decades ago. And yet, they're still alive, still sending faint whispers from more than 23 billion kilometers away. Each signal that reaches Earth today left Voyager almost a full day earlier. A message from a machine older than the internet, still keeping its promise to report back home. So, how did a pair of spacecraft, built with 1970s tools and optimism, outlive almost everything that came after them? This is the story of Voyager, how two aging probes became humanity's oldest voice among the stars. Back in the mid-1970s, the world looked very different. There were no smartphones, no internet, not even compact discs. Most people still got their news from paper and TV, and space felt like a short story that had already ended after the moon landings. Yet, in a quiet corner of NASA, a small team of engineers was sketching something extraordinary: two spacecraft that could visit every outer planet in one sweep. To make that happen, the planets had to align in a way that only occurs once every 176 years. Miss that window, and the chance was gone for generations. So they built quickly, by hand mostly, using slide rules, soldering irons, and determination. Each probe had less computing power than a basic calculator and recorded data on 8-track tape. But they carried something no other machine had before: a golden record engraved with our music, our voices, and our story. A message to anyone or anything that might someday find it. Voyager wasn't just about science, it was a statement. Proof that even after we stopped walking on the moon, we still looked outward. And maybe that's why it matters so much. These two small probes became the farthest fingerprints humanity has ever left in space. What none of their builders could have guessed was how long those fingerprints would last. When Voyager was built, NASA wasn't designing a 5-decade mission. They were designing something that could simply survive long enough to see Jupiter and Saturn. But the engineers knew that if they did their jobs well, these machines might just keep going. So they quietly built in more endurance than anyone asked for. Each Voyager carries 3 radioisotope thermoelectric generators, small power plants that convert heat from decaying plutonium into electricity. They produced about 157 watts at launch, roughly enough to power a modern laptop and charge a phone at the same time. It doesn't sound like much, but in space, efficiency is everything. The RTGs would lose power slowly about half every 87 years, giving the probes a steady, predictable supply for decades. Then came the backups. Almost every critical system, from thrusters to gyroscopes, had a twin waiting in silence, ready to take over if the first one failed. That foresight is why, 37 years later, when Voyager 2's main thruster stopped working, NASA switched to the backups. And they fired perfectly after 4 decades of sleep. Even the computers were built with this mindset. They weren't fast or fancy, but they were tough. Built to handle cosmic radiation and coded to recover from glitches on their own. While your phone might crash from a single software bug, Voyager's systems can catch their own mistakes and fix them without ever hearing from Earth. It's the kind of design that feels almost old-fashioned today: simple, cautious, and reliable. But that's exactly why it's still alive. In an age obsessed with speed, Voyager was engineered for patience, and that patience would soon pay off when the 2 probes began their long journey past the gas giants, a tour no human had ever seen up close before. The moment Voyager reached Jupiter, everything changed. Those first close-ups revealed storms the size of Earth, lightning that flashed through clouds deeper than any ocean, and a great red spot so massive it could swallow 3 planets whole. Until then, Jupiter had been just a fuzzy dot in a telescope. Now it looked alive. The probe's cameras caught volcanoes erupting on Io and icy cracks on Europa, hinting that something might lie hidden beneath its frozen crust. Each discovery felt like a postcard from another world. Then came Saturn, with rings so thin and delicate that light could pass straight through them. Voyager 1 watched its moon tighten through a hazy orange atmosphere and found that it wasn't just a rock, but a world thick with nitrogen and mystery. When Voyager 2 continued onward to Uranus and Neptune, it became the first and only visitor we've ever sent that far. It found Uranus tipped almost on its side, spinning like a rolling ball, and Neptune's winds screaming at over 2,000 kilometers per hour, faster than any hurricane on Earth. These weren't just pictures, they were first-hand encounters, proof that our solar system was stranger and more beautiful than we'd ever imagined. And as the last blue glow of Neptune faded behind it, Voyager 2 didn't stop. It simply kept going, into the dark, carrying the memories of every world it had passed. But beyond the planets lay a region no spacecraft had ever crossed, a place where the sun's influence begins to fade and interstellar space begins to take over. To survive there, Voyager would need every bit of the endurance its designers had built into it. By the time Voyager had left the last planet behind, its mission was already far longer than anyone expected. Power levels were dropping, its instruments were growing cold, and even a simple command from Earth took almost a full day to arrive. The engineers began switching off non-essential systems one by one, hoping to stretch the remaining power just a little further. Cameras went dark, heaters were shut down, and experiments that had once dazzled the world were quietly silenced. It was like watching an old ship dim its lights to survive another night at sea. Then came the moment that nearly ended it. Voyager 1 began sending scrambled telemetry, lines of nonsense numbers that made no sense at all. Some thought its computer had finally failed, but the team refused to give up. They traced the fault, found that one system had started routing data through a dead computer, and manually switched to a backup that hadn't been touched since the 1970s. It worked. Voyager 2 faced its own crisis years later when its main thrusters stopped responding. Engineers woke up its backup set after 37 years of silence, not knowing if they'd still ignite. They did. Perfectly. The little bursts of gas from those thrusters nudged the spacecraft back into position, a small correction that kept its antenna pointed toward Earth. Each time something failed, someone on the ground found a way to bring it back. It wasn't luck. It was the result of design decisions made decades earlier by people who believed that simple, sturdy systems would outlast fancy ones. Today, many of those engineers have retired or passed away, yet the machines they built are still listening, still answering. Every signal they send is a living echo of that persistence. But beyond the fading power and the aging hardware, Voyager was about to face a test no machine had ever survived: the edge of the sun's domain. As Voyager pushed farther away, its sensors began to notice something strange. The stream of charged particles coming from the sun, what we call the solar wind, was slowing down. Then suddenly it dropped off completely. For decades, scientists had only imagined where the sun's influence might end. But now Voyager was there, measuring it firsthand. In 2012, Voyager 1 became the first human-made object to cross the heliopause, the invisible border where our sun's bubble ends and interstellar space begins. The readings changed almost instantly. The flow of solar particles disappeared, and high-energy cosmic rays from deep space surged in. For the first time, a machine built by humans had left the solar system. Voyager 2 would follow a few years later, confirming that its twin wasn't alone. Both probes found that this boundary isn't smooth like a wall, but more like a turbulent sea, constantly shifting and rippling under the pressure of the sun's breath. Out there, space isn't empty. It's filled with a thin soup of plasma and magnetic fields that Voyager can still sense even now. The signal that carries those measurements back to Earth is barely more powerful than a refrigerator light bulb. and yet it travels more than 23 billion kilometers to reach us. When you think about it, that's incredible. Something no larger than a small car, powered by less energy than your kitchen microwave, still talking to us from beyond the reach of the sun. But as every year passes, its power fades a little more and each transmission might be its last. The silence waiting beyond that final signal is what comes next. Sometime soon, maybe within the next few years, the Voyagers will grow quiet. Their power is fading, one instrument at a time, and eventually even the radio transmitters will fall silent. When that happens, they'll keep drifting, no longer spacecraft, just silent travelers carrying everything we once wanted the universe to know about us. Each probe holds that golden record, sealed in a cover etched with instructions on how to play it, a kind of cosmic mixtape of Earth. It carries greetings in 55 languages, sounds of rain and wind and laughter, and music that stretches from Bach to Chuck Berry. If someone or something ever finds it, they'll hear the sound of our planet breathing. NASA estimates the records could survive for more than 1 billion years, long after our continents have shifted and our cities have turned to dust. Long after we're gone, Voyager will still be out there. Proof that once we tried to reach beyond ourselves. And what comes after it? New ideas are already forming. Engineers are designing an interstellar probe, a mission that could travel twice as far in a fraction of the time, using technology that didn't exist when the Voyagers launched. Maybe in another half-century, a new signal will cross the void, carrying forward the story these two began. But no matter how advanced our future missions become, nothing will ever replace the feeling of what Voyager represents. Hope, curiosity, and the stubborn refusal to stop exploring. For now, the signal still comes in. Faint, delayed, a whisper from the edge of forever. And somewhere in that whisper, you can still hear us. It's strange to think about it. Something built by human hands now farther from home than anything else we've ever made. Somewhere out there between the stars, Voyager keeps moving through the dark, carrying the sounds of our world. The laughter, the storms, the music, the heartbeat of a planet that still looks up. When it finally stops speaking, no one will hear the moment it happens. The last signal will leave the spacecraft, travel for more than 20 hours, and fade quietly into static. But even then, the journey won't really end. Because Voyager isn't just a machine. It's a message. A reminder that curiosity can outlive its creators. That even small things, when sent with purpose, can travel forever. Maybe one distant day someone will find it. Maybe they'll hold that golden record and wonder who we were. And if they listen closely beneath the music and the greetings, maybe they'll hear what we were really trying to say, that we were here,